This video is an introduction to the idea of formal semantics. At this point, our approach in the course splits. Thinking about QL, what we want is both a semantics, where semantics is a theory about meaning and truth, and a proof theory, which is about constructing arguments. We'll see at the end of the course that semantics and proofs complement one another. If we want to show that an argument in QL is invalid, we do that by working in the semantics to show how it's possible for the premises to be true and the conclusion false. To show that an argument is valid, we provide a proof to show that the premises lead to the conclusion. Chapter 5 of the textbook is about semantics, and that's what we'll be concerned with for the next few weeks. We'll deal with proof theory further on in the semester. Let's start by thinking about the semantics of SL. From truth tables, you already know about how meaning and truth work in SL, but maybe you haven't thought about them in this way. Everything we can write in SL can be written with symbols from this list. There are sentence letters, there are 5 sentential connectives, and there are parentheses. We were able to give a formal definition of a well-formed formula and a sentence of SL in terms of how these symbols fit together. We can call the connectives in parentheses logical symbols because their meaning is specified by the structure of SL itself. The ampersand always means conjunction. It always means and. You can't make it mean something else. And because it always means the same thing, you don't have to specify what it means in a symbolization key. The sentence letters, on the other hand, are non-logical symbols. Their meaning depends on the symbolization key. What capital B means depends on what context we're talking in. Suppose our symbolization key specifies that M means today is Monday, and R means it is raining. Okay, ask yourself, is M true or false? Is R true or false? Now, I can't say because I don't know when you're going to be watching the video. I don't know what the weather will be like when you're watching the video. Is M true? That's something I can't tell you. So the symbolization key alone doesn't determine whether the sentence letters are true or false. It depends on the symbolization key, but it also depends in a broad sense on what the world is like. What day is it? What's the weather like where you are? The only significance that the sentence letters have in SL are their truth value. That is, the symbolization key plus what the world is like determine the truth value of the sentence letters, but it's only the truth value of the sentence letters that affect how sentences turn out in SL. Suppose that it's Monday and it's not raining. Then M gets a value of 1. R gets a value of 0. Once we've specified these truth values, we can do all the work in SL without thinking again about the symbolization key or about what the world is like. M might as well be any true sentence. In SL, the sentence letter M isn't particularly about days of the week. And R might as well be any false sentence. In SL, it's not especially about the weather. Now consider a compound sentence like M and R arrow M. Its truth value just depends on the truth of its parts. If M happens to be true and R happens to be false, as we've supposed before, then the compound sentence gets a value of true, 1. It's like one row of a truth table, one way that things can be. A truth value assignment is a mathematical function that answers 1 or 0 for each sentence letter. You can think of it as being like a row of a truth table, but for all the sentence letters. A truth value assignment is enough to calculate the truth value of every sentence of SL. That's because the truth value of long, complex sentences can be calculated from the truth value of the sentence letters they contain. That's what you do every time you fill in the row of a truth table. Technically, to say a sentence of SL is true always assumes some truth value assignment. The truth value assignment is what makes the sentence true or false. So you can think of a truth value assignment as being a way the world could be. There's one that represents the actual world, and the others are different logically possible worlds. When we're thinking about a sentence or a list of sentences, we can specify all the possible truth value assignments. That's what we do when we construct a complete truth table. Every row of a truth table represents a way the world could be, and in a complete truth table, we consider all the relevant possibilities. A sentence is a tautology if it's true in all possibilities. And in SL, we could check that just by listing them. What we want to know now is, what is it in QL that does the work that a truth value assignment does in SL? The answer is going to be a model. We won't be able to list all of the possible models, so we want to have a procedure like truth tables to test sentences or arguments of QL. That's something we'll see later. This video has been mostly conceptual, but it's meant to motivate what we do next. We're going to develop models and a semantics for QL.